Okay, so here's your review. Okay, so when guys, ready? Dialed in? Okay. So I'm going to be using, right, the mathy terms. So when I'm talking about the radical, okay, I'm talking about like the whole thing. This whole thing is just called the radical, okay? And the radical is made up of a couple parts, right? There's a number in front. There could be a number in front, and that's called your coefficient, right? It could be positive or it could be negative. Okay, that's your number in front. And then, of course, you have your index. So if there isn't a number written in that index spot, what do we assume it to be? Yeah, 2. We're going to assume that it's a square root. Otherwise, it's going to have, you could have a cubed root, fourth root, and anything root. What you want to make sure is that you know how to get to these features on your calculator. Okay, so pull out your calculator. Okay. Head over here. So, okay, your regular square root button, right, should be like right above your squared. Okay, and then depending on the version that you have, okay, if you hit math, you're going to see that they have a built-in cubed root, and then they should also have an X root, where you can tell it what the index is. Okay, so on some calculators, you can just hit this, like you can just hit number 5. Okay, and see, my calculator, I have to put the number in first, okay, and then tell it. And then for other people, it gives you like a little flashy box, and you can just arrow over and you put in the index. So just make sure that you know what your calculator wants. So for example, if I wanted the fourth root of something, I would have to type in 4 first, and then math, and that guy, and then it puts my 4 in. Okay, so just make sure that you know the nuances of your calculator. Okay, and then of course we have the radical sign. So we don't call it a square root sign technically, or a root sign, because we call it a radical sign because it could be a cubed root or it could be a fourth root. And I know some of you, like in our last unit, when it asked you for the roots of the equation, your brain went to square roots rather than roots being the same word that we use for solutions or for x-intercepts. Okay, why do they call it a root? Like, why do they call our solution a root? I'm not sure, because it does kind of conflict with our radicals being roots as well. Okay, and then of course the number underneath the radical sign is your radicand. Okay, so sometimes we talk specifically, like when we talk about the discriminant as part of the quadratic formula, the discriminant is actually the radicand, right? It's the thing that's under the square root sign. Okay. So radicals in simplest form, so treat radicals with the same mindset that you would about a fraction. Okay, so if I gave you the fraction 4 over 6, okay, I would expect that you would turn it into simplest terms, right? And that you would turn that into 2 over 3. Okay, without me ever asking, like you don't ever have to say, do you want this in simplest terms? Yes, always. Radicals, same thing. Okay, you have to put it in simplest terms. So we did a little bit of a review when we were doing our quadratics. And so we're just going to I'm just going to write a few things in here. So the radicand, guys, cannot contain a fraction. And we typically, sorry, I'm just getting my notes here for, all right, here you go. Yeah, if you, yeah, because I'm in the lesson that I already marked absent. Sorry. Okay. So the radicand's not going to contain a fraction, guys. The radicand does not contain a factor that can be removed. So what that's talking about is, here we are, pens. Okay, so for example, if we had square root of 54, right, you just have to like trickle through your brain and say, okay, I'm thinking about all my perfect squares. If you wanted to write like a list of all your perfect squares somewhere, right, and you're just kind of going like 1, 4, 9, 16, 25, 36, 49, like, right, you just to like get them back in your brain a little bit, that'd be great. Okay, so I'm looking at 54, I'm saying, okay, what 2 factors could I pick with one of them being a perfect square? So you'd want to remember that this is the same as 9 times 6, and then we actually take the square root of 9, so we end up with 3 root 6. Okay, so whenever you have something that has a radical, always, okay, always simplify it. okay? And okay, here's the thing that we learned a little bit, like if you did grade 10 AP, you would have seen this. Okay, we introduced it then, okay, but we're gonna reintroduce it again. When we have a fraction, the denominator, this again is just mathematical convention, okay? We never have a radical sign in the denominator, okay? We always do something that's called rationalize. I'm looking to see if I have my definition. No. Okay, but I'll show you what that is. Okay, so for example, this is where you saw it. So last year, remember when we did special triangles? Okay, maybe you don't remember. I'll just jog your memory a little bit. Okay, last year when we did special triangles, we had okay, this was one of the special triangles where it was like 45, 45, and 90. Okay, and we were talking about, so remember if we were like looking at this angle, okay, and we wanted the sine of 45 degrees, we would say sine, we're like, oh yeah, SOHCAHTOA, right? So sine is opposite over hypotenuse. So opposite is 1 over our hypotenuse is root 2. Okay, we didn't stop there though. We said, no, we have to rationalize the denominator. And what that meant is we multiplied top and bottom by root 2 over root 2. Because we wanted to get rid of the radical sign on the bottom. Because what's root 2 times root 2? Okay, we have two options. You can either, like when you multiply radicals together, right? Like say I had root 6 times root 3. Guys, we would just like multiply those numbers together and put them all under one radical sign, right? And then we would look at that and we'd say, oh yeah, I can simplify that. Okay, so for here, root 2 times root 2, technically it's root 4. Okay, but what's the square root of 4? 2. So what you're going to notice is when you multiply a radical by itself, it's like it undoes, like it like doubles up on that square root sign, and you end up with the radicand as your, like it comes out of the square root sign, okay, because there's 2 of them. Okay, so what I want you guys to do is go from this point, you can skip this step, and you go right to here. Just recognize that root 2 times root 2 is 2. Okay, so if I had 1 over root 3 and I had to rationalize it, I would multiply top and bottom by root 3, and I'd have root 3 over 3. Okay, we're going to spend a little bit more time on that. We're just going back to our summary. Okay, so that is denominator does not contain a radical. So this is just my little example. Okay. There are going to be restrictions. Okay, this might be new. There are restrictions on variables in the radicand if it has an even index. Okay, and the reason is, guys, can I do this? Can I take the square root of -9? No. Okay, if we did it on our calculator, it would give you this error, right? Okay, so we have to have restrictions when we have an even index. Guys, can I do this? Can I take the cubed root of -27? Yeah, what is it? -3. Okay, so if it's an odd index, we're okay. Only if it's an even index, we're going to put restrictions. Because what we're going to be learning is, we're going to be doing stuff like, we're going to do the square root of x. Okay, we're going to put some variables in our radicand. Okay, but then that means that if we have a variable underneath our radical sign, we're going to have to put a restriction on it. So what can x, okay, what can it not equal? Like, what can it not be? Let me say it that way. What can x not be in general? A negative number. Absolutely. Okay, so that's what we're going to be doing here in our first exercise. We're going to focus first on our restrictions, because every single time you guys do work with a radical that has a variable underneath, you have to write the restrictions. Okay, it's part of the answer. Okay, at the beginning, it will remind you, like, what are the restrictions of this? Or what is the answer and restrictions? Okay, eventually it'll like leave off the command to write the restrictions with the understanding that that is just part of the answer. Okay. So determine the restrictions of the variable. The way that we do this, okay, is we take whatever the radicand is, okay, and we say that it has to be greater than or equal to 0. Okay, because can we take the square root of 0? Yeah, that one's okay. So it just has to be greater than or equal to 0, which means it has to be positive. Okay, so first we look to see, okay, is the index even? And in this case, all of our indexes are even, so I'm not going to ask the question again. Okay, and so this case, so now we say, okay, in this case, we want, oh, let me just do this. Okay, so are there going to be any restrictions on x squared, the square root of x squared? Is there a number that x can't be? Okay, if x was -3, we would square it first, it would become 9, and then we would take the square root. So this one, okay, if it has a squared underneath, there's no restrictions. Okay, because you do the radicand first, okay, and so this one has no restrictions. Okay, what if we did the squared second? What if we did it on the outside? Are there restrictions on this one? Because you might say, well, doesn't the square root, and if you square the square root, doesn't that like cancel it? Okay, guys, order matters here. We still have to follow BEDMAS. BEDMAS says we do brackets, then exponents. So technically, this would be our question first, square root of x, which does have restrictions. Okay, then we would square it. Okay, so just pay attention to some of the little nuances that are going on. Okay, and then we're just going to like add a little bit, like we just like looked at what it was when it was a plain x. Now we're just going to add a little bit to the radicand. So you take the entire radicand, which is x minus 4, and you're going to say that has to be greater than or equal to 0. Okay, so do you guys remember inequalities? Maybe we'll just do a little refresher on inequalities. Okay, when we have an inequality, you basically treat it like an equal sign, right? So in this case, we would do this. So x is greater than or equal to 4, right? Because if x was 3, for example, 3 minus 4 is -1, and we can't take a square root of a -1. Okay, so that makes sense. So you can even just do a little quick check. Okay, if x was 0, that's not greater than 4, okay, we'd still have a negative. With our inequalities, let's go back to my little notes here. Okay, so with inequalities, let's say we had this, 2x minus 3, okay? Say we just like, it was sort of like an equation, but it's an inequality, okay? We would treat it like an equal sign. We would add 3 to both sides. 2x greater than or equal to 10, divide by 2, okay? And well, that would be a 5, okay? So it works just like an equation, except, okay? Except, here's our exception. If we had, I'm just looking at my example here. Okay, if we had this, okay, so we still do the same thing that we just did. We have -2x greater than or equal to 10, okay? We're dividing by a negative number, okay? So x is going to be, okay, is my inequality still true if it's greater than or equal to? So let's say, for example, I'm going to choose the number, let's just choose the number 1. Okay, if I subbed 1 in here, I'd have -2, okay, minus 5. Is that greater than 7? I didn't explain that one very well. Okay, give me a second here before I do my example. Okay. What happens? So this is where I'm going. Okay. When we divide or when we multiply by a negative, our sign, our inequality sign changes. Our inequality flips. Okay, some of you are going, I seem to remember a strange rule about that when we multiply or divide by a negative, our inequality sign flips. Okay. I'm just looking at my own example and I'm like, I don't even understand my example. Okay. I will come back to it. I will circle back around because I was like, when I divided by a negative. Okay, so this is what I have for my example. Okay, I had just a very simple thing. I had 7, okay, is greater than 5. I divided both sides by a negative. Okay, is negative 7 still greater than negative 5? No. So when I divided by a negative, okay, I had to flip my sign. Okay, because what I did to one side, I did to the other, so that should preserve my equation, right? However, when you multiply or divide by a negative, just remember to flip your sign, okay? All right. And we'll see, oh, here, important note. When working with an inequality, if you multiply or divide, so it's in your notes, guys, if you multiply or divide by a negative number, the sign of the inequality flips, okay? So we'll get to that. Let's just do these ones. Okay, 2x minus 1 greater than or equal to 0. Okay, 2x greater than or equal to 1. X greater than or equal to 1/2. Okay, 5 plus x. Okay, so we can subtract 5 from both sides. X has to be greater than or equal to negative 5. Okay, so the rule here is, okay, you're just going to take the radicand, okay, and make that greater than or equal to 0. So whatever the radicand is, greater than or equal to 0, these are your restrictions. Yeah, that's fine. All right, in these questions, okay, so here we have, okay, negative x is greater than or equal to 0. I'm going to divide by negative 1. So x, we flip the sign, okay, has to be less than or equal to 0. Okay, guys, why didn't we, okay. Why didn't we just move the x? Okay, like if we go back to here, I just want to explore this for a quick sec. If we did this, okay, we could just move the x over, right? We could add x to both sides. Okay, so we would have this, okay, which is still true, okay? However, we read left to right. And so what I don't want to see this as an answer. I want your x's first, okay, and then the answer. Now, if you did this and you know, okay, well, now I got to like read it. I want to say x, like you know that when you read it, now you're sort of like reading from right to left. So you would just rewrite it this way. Okay, so in a sense, both strategies will get you to the right answer, but typically by convention, we tend not to move the x. It's better to just divide it by negative 1 and flip the inequality so that the x stays on the left. Here's another example. 3 minus x greater than or equal to 0. So I'm actually going to keep the x on the left, and then I'm going to divide by negative 1. Okay. So Right, so if you're feeling like you're getting this, go ahead and do the next two. Yeah.
So X always greater than or how do you know when?
Okay. All right, let's finish these up. 1 minus 3x greater than or equal to 0. Let's get my negative signs in there properly. All right, so hopefully you got x is less than or equal to 1/3 and x is less than or equal to 5. Okay. Okay, so here we are. So we're going to do a little bit of review so that we're like up to snuff. So guys, this is, I kind of already introduced this. I want you to do the next 6 questions. I want you to write each, okay. So an entire radical means like everything is under the radical sign. Okay, there's no coefficient. That's what an entire radical is. What we want to do is write an equivalent mixed radical. So that means that you're breaking apart the radicand. You're looking for your perfect square numbers. Okay, and so now your mixed radical is going to have a coefficient and something left over in the radicand. Okay, now you guys are at the point, okay, you do, like, this is how we do it. Okay, I'm good if you're doing mental math and you can like visualize in your head, right? 4 times 3, square root of 4 is 2. So if you just go straight to, right, you know that this is 16 times 2, okay? This one you could say 25 times 3, so 5 root 3, okay? So if you can do that, you're okay to do that, okay? If you'd like to write in the middle step, please write the middle step. Okay, I'm giving you a little bit more freedom though to do some of the mental math. Okay, and then remember your perfect cubes. Okay, our perfect cubes. Okay, I just wrote them down there. So this one we're looking for 8 times 2, 2, and then the cube root of 2. Okay, guys, do not drop your indexes. Okay, make sure that there's a little 3 in there because otherwise you're writing the square root. Okay, you will lose a mark if your index is incorrect. Okay, and then 125. Right. Right. The next thing. So that was our review. This is still review. Now we're actually taking, we have to make sure that we can like reverse engineer that, right? That we can do the opposite. Okay. Go from mixed radical to an equivalent entire radical. So this is where we're like pushing what the coefficient that's in front, we're pushing it under the radical sign. Okay. 2 ways to think about this. You choose which way you like. So you can either, so you remember that the square root has, right, an index of 2. So some people like to think of it as they take the radical and then they take the coefficient and they're going to multiply it by itself however many times the index tells them to. So 2 times 2. Okay. Other people kind of visualize it like they multiply the coefficient and they use that index as the exponent. Okay, those two things are exactly the same. Okay, so here again, you're moving up to root 20. Okay, so I tend to, I'll probably write it like that. Okay, again, if you can, I don't need to see every single step. right? Like you don't have to say 2 times 169, you know, and then equals. You guys can do some of that. Okay. Okay, or it might be like that. Okay, 25 times 2, square root of 50. Okay, cubed root. Or you could write it like this. Okay. So these two, I certainly don't need to see them both. I'm just letting you know that these are equivalent. You could pick one or the other. Oh, hello. We're just like deciding to launch a new window. I don't know. Do you want to continue? You can just go away. All right. Okay. We're just like moving right along. Here we go. Express each radical as a simplified mixed radical with variables. Okay, so now what we're doing is we're going to be breaking apart our radicand. Our radicand is going to have a number. Yeah.
Do we have, on the last page,
Yeah.
do we have to show one of those two steps?
No, if you want to, if it helps you be organized, but if you're like, got this one, you just write it down as a full-on one. Yep. Okay, so now we're introducing some variables underneath our square root sign. Okay, so we have to remember how to, okay, there, again, for you guys get like the multiple strategies. You can think of it like this, you can think of it like that. Okay, so I'm always going to like show you different ways to think about it. One of the ways to think about it is to remember back from last year that we could write a radical as an exponent that's in a fraction. Okay, so whatever the index is, the index would become the denominator of our fraction when we do it into exponential form. Okay? Other ways to think about this is you could, okay, what I like to do is I would actually take the exponent and I would like divide it by the index, right? 2 divided by 2 is 1. So when I pull the x out, there's going to be 1 x that gets pulled out. Okay, other people might like to like group, you know, have separate groups of the variables and to see how many groups that they take out. Okay, so we'll just kind of like explore a couple ways and refine that. So in this case, I know that for sure I'm taking the 9 out, okay, and then I have my x squared. Okay, so when I take an x squared out, we're going to, oh, sorry, I'm going to start with the 9. Okay, we're taking a 3 and then an x, and we're left with the root 6. Okay? Guys, are there any restrictions? Because I just have it in, I have a variable in my question. Any restrictions on x? Nod or shake your head. Any restrictions on x here? No, because, okay, x is squared. We can have a squared number under an even index. Okay, so there's no restrictions. Okay, this one I'm looking at, what, 32 times 2, x to the power 4. Okay, so I'm taking out a 6. Okay, I'm going 4 divided by 2 is 2, so I'm taking out an x squared. And I'm left with square root of 2. And yes, these all have nice little, beautiful, lined up equal signs because I'm showing equivalence. Okay, if you feel like you're getting this, okay, then go for square root of 50 times x to the power 4. Yeah, I'm gonna make sure I leave time for that. I haven't filled out all my tickets yet.
Yeah.
Okay, let me.
Yeah.
I got a couple more examples, so I should have time.
No.
Go.
Oh,
Okay. Okay, I got to speed things up a little bit here. So we have 5x squared root 2. Okay. Okay, so you'll notice, okay, the question even gives you the restriction because now we have an odd exponent under an even index. So there will be restrictions. Okay, so the same thing happens. So this one we're going to look at. So we still have 16 times 2. Okay, if you want to look at it like this, we have an x squared. Like if I were to break apart the x to the power of 3, okay, I could break it into like a nice little group of x squareds, and then you're going to see that you have like one left over. So when I take the square root of all this, square root of 16 is 4. The square root of my x squared is x, and I'm left with a 2x still underneath my radical sign. Okay, another way of thinking about this, I did 3 divided by 2, which is 1.5, right? So 1 and something left over. So, okay, and x came out, that's my 1, and then this is my leftover. Okay, so 98, it would be 49 times 2. Okay, if you want, you can, okay, you can pull out, these are all being like multiplied by each other. You can pull it out into groups so that you can see we're doing a 7. Okay, we're doing an x and a y squared comes out, and we're left with a 2xy. Okay. So here we have 100 times 2. Okay. You don't have to break it into groups. You can leave it as odd exponents. Okay. If you can recognize that I'm taking an x squared out, and so I'm leaving behind an x. I'm taking a y to the power 4. Right. I'm taking the square root of that. Okay, and I'm left with the y. Okay, so your choice whether you want to break it into groups and show that or not. Okay, if you're good with knowing that you're taking a squared out and you're taking 2 y squareds. Okay, express each mixed radical as an equivalent entire radical. Okay, so just remember that when the 2x goes under, okay, guys, we're squaring it and we're multiplying it by itself twice. So you have to, okay, you have to square the coefficient and you have to square the variable. Okay, so 2 squared is 4, 4 times 5 is 20, x squared. Are there any restrictions that we need to introduce? Because I have a variable under a radical sign. No, not in this case because my exponent is even, okay, and my index is even. Okay, so in this case, we're doing 2 times 13x. Okay, it gets squared when we put it under. Okay, so we have 169 times, should be a 2. Okay. Okay, so just make sure that we can. Okay. Okay, so don't forget, now we're going back to grade 10 and we're doing all of your exponent laws. Okay, we're doing power of a power. So when we have this, don't forget. Okay, yeah, I don't know why my colors just looked weird. There we go. Okay, don't forget every term, okay, gets squared. So the 5 gets squared, the x gets squared, the y squared gets squared. Okay, so we have 2 times, okay, this is 25 x squared y to the power 4. Okay. How are we doing for that? This one's going okay? Okay. And so in this case, we would just, when the index changes, Okay, we would just cube it instead. So 2 times 4 cubed is 64, x cubed. Okay, 128 x cubed. Okay, this class goes by so fast. Okay, guys, I have good news for you. Okay, no homework this weekend. Okay, I will finish this up on Monday. You'll get some homework on Monday. However, okay, I'm going to hand out your 10 a week. Okay, that